You are first-timers, so welcome for your first time here. Those of you who have come back, it's really great to have you back with us. So I have one announcement that's pretty important today, and that's about a schedule change. So if you were planning to go to Best Practices Getting Up and Running in AR at 9:30 a.m. in room number 2, that is actually now occurring at 2:30 p.m. And so they have switched places with Practical Frameworks for a Voice-Enabled Future, which is now at 9:30 a.m. So you'll just flip those two. Again, Getting Up and Running in AR is now at 2:30 in room number 2. So that means Practical Frameworks for a Voice-Enabled Future is now at 9:30 in room number 2. So I just wanted to say that this conference would not be possible without all of our committee members. You can see them standing in the back and kind of around everywhere with these blue committee ribbons on. They're also responsible for making sure that we have a safe conference, so if you ever need anything, you can just come over to any of us with a blue ribbon. In addition, we have volunteers that have green ribbons, and they're also available to you. Because we're running a little late, I'm just going to get to it. We have two fabulous keynotes today. Our morning keynote is a St. Paul native, which is super exciting. Her name is Dr. Wright Steenson. Her work focuses on the intersection of design, architecture, and artificial intelligence, and we're really happy to have her here today.
Good morning. It's awesome to be back in the Twin Cities. I love this place very, very dearly. I have a habit of naming talks when I give them here after some of my favorite musicians and some of my favorite songs. And so I named this particular talk Sometime to Return because of the band Soul Asylum and their 1988-89 or so album. And there's a vague bit of history in that term, in part of the song. And in the chorus. So that's my shout out to hometown folks, Soul Asylum. I'm the author of a book called Artificial Architectural Intelligence, How Designers and Architects Created the Digital Landscape. It's on MIT Press, and some of what I'm going to be talking about today is covered in the book. It's a digital history of architecture and artificial intelligence, and an architectural history of the web and UX. And if you are wondering how those things come together today, I will give you a little bit of an idea. And one of the reasons why I think these things are important is if you Google the word or the term AI in Google image search, here are some of the things that come up. So you get something like this, a lot of black and a lot of blue. You get the wireframe head, and these white rays coming out from the head and kind of a glowing, I don't know, neuron something or other. You get behold the hand kind of images. I like her, cyborg lady. There are a lot of cyborg ladies. I think this is jQuery, am I right? If this is the future, I think we're in trouble. And I want to point out something, that AI isn't the new anything. We talk about it as though it's new, because it's not new. And here's how new it isn't. We coined the term artificial intelligence, John McCarthy did, in 1955, when he said that AI was making machines do things that would require intelligence if done by man. In 1956, he gathered a group of people at Dartmouth College to hash out the research platform for artificial intelligence, looking at things like natural language processing and game playing and neural nets and machine learning. He brought together all of the men, I will point out, most of the people that I'm going to talk about today are male, all of the men who put in place that research foundation. Herb Simon, Alan Newell, and J.C. Shaw. Simon and Newell are former professors at Carnegie Mellon, where I am a professor. Believed that they would have artificial intelligence pretty much solved by about 1960. They said intuition, insight, and learning are no longer exclusive possessions of humans. Any large, high-speed computer can be programmed to exhibit them also. So they figured they'd have this done by about 1960. And then there are people like J.C.R. Licklider, who I'm going to mention again in a few minutes. sometimes, you may be familiar with the idea of human-computer symbiosis, right? That you put the human and the computer together, you get something that's bigger and better than the sum of the parts. That's an idea that he wrote about in 1960 and was the operative idea for all things interactive for decades. And we still use this terminology today. We could look at someone like Marvin Minsky, who in 1961 wrote, "I believe that we are on the threshold of an era that will be strongly influenced by and quite possibly dominated by intelligent problem-solving machines." You could look at the beginning of machine learning. 1952 is really where it begins to be popularized, although the notion of machine learning even existed before this. Arthur Samuel fed a computer a lot of different rules for playing checkers and started playing against the checkerboard, playing against the computer. And the computer would learn as a result. And this is where machine learning comes from, 1952. And ideas of things like neural networks, neural nets. Here's 1958. And in a New York Times article, it stated that the Navy revealed the embryo of an electronic computer today that it expects will be able to walk, talk, see, write, reproduce itself, and be conscious of its own existence. It said that this perceptron, which was that kind of machine, this thinking machine, would be the first non-living mechanism capable of receiving, recognizing, and identifying its surroundings without any human training or control. And that line of AI research got shut down by Marvin Minsky and Seymour Papert in the late 1960s because they disagreed with it and wanted to see research funding go somewhere else. Another thing that we'll see a little bit about in this talk today is how agendas shape artificial intelligence research. So my question is, if AI's ideas are so old, why do we talk about them like they're so new? And this is what I'm talking about. Again, AI is the new black. AI is the new UI. It's the next digital frontier, according to McKinsey. Andrew Ng said AI is the new electricity, but then he left his company and started a MOOC, massively online course. And now AI is, his MOOC will teach us to serve an AI-powered society. If you want to have artificial intelligence, you need data. So data is the new oil. Google's AI is a new paradigm that unites humans and machines. In this screenshot, I just went through and highlighted the word new, and I got 6 mentions, though one of them is New York, so it probably doesn't count. But we look at how video games are the new AI. But this is what it comes down to, I think, is people like Elon Musk saying that we are at an era of artificial intelligence. And people like Elon Musk have a lot to gain by us believing that AI is new. I want to point out here, you can gather from the talk and maybe from how I set up the talk and from my book that I'm curious about architecture and design. And I also want to point out that AI architecture and design have been working together for a long time. They're not strangers. In fact, they're friends, and at that, very old friends. And you can even look at how AI research turned to architects and architecture as a way of talking about the world. So this is the first computer mouse created by Douglas Engelbart in 1964, and then on the right is a later patent drawing from 1968. I like the fact that it's made of wood and steel. And in 1968, he did something that's referred to as the mother of all demos. It's worth going and seeing on YouTube if you haven't watched it. It's a demo of a hypertext linked voice-activated system for information. It was called the NLS. And again, it's referred to as the mother of all demos. But even before he did this, before Douglas Engelbart did this, in 1962, he came up with something that he called augmented human intellect, which was his idea about humans being able to work with machines to design things in the world. And his first example of all of this was what he called an augmented architect. So he describes it as follows. He says, let us consider an augmented architect at work. He sits at a working station that has a visual display screen, some 3 feet on his side. This is his working surface, and is controlled by a small computer with which he can communicate by means of a small keyboard and various other devices. What do you think this is about? Why is he reaching out to talk about architects when he's an engineer? I think that one reason is that architecture gave technologists a way to build worlds, because that's what architects do. So this is a part of the history of UX and digital design. And here I'm going to verge into talking about 3 architects who worked with artificial intelligence and the impact of those practices on UX and beyond. And give us some ways maybe today of thinking about AI in the world. And there's going to be a lot of material coming by, so consider it to be like caffeine. So first of all, Christopher Alexander. Has anyone here heard of the architect Christopher Alexander and maybe a book called A Pattern Language? See a couple of hands? Yep. I think more hands will go up as I work through this a little bit. Christopher Alexander defined how programs and UX people and interaction designers talk about architecture. And he's also inspired a lot of different things. He's inspired object-oriented programming, the wiki format, agile and extreme programming, human-computer interaction, software interaction in UX design, and information architecture. Not bad for an architect and mathematician who had nothing to do with the World Wide Web. He did most of it in the 60s and 70s. He's still alive today, was born in 1936. He's written a lot of books, but 2 that he's best known for are Notes on the Synthesis of Form, which was his dissertation in 1964, published in 1964, and A Pattern Language in 1977. So if this is a book you've seen, it's thick, it's about this big, it's the #1 selling architectural criticism book on Amazon, always. And it is a set of patterns. I'll explain what that is in just a second. And I want to point out, in Notes on the Synthesis of Form, he argues for the fact that design, good design, is the absence of bad fit, right? He wanted to come up with a way of describing design as a structure that would be mutable, that could change, that could shift. It isn't like coming up with a beautiful building, but rather describing the structure of that building. And this is a really attractive idea for technologists, for web people, for interaction designers, for people like us. It's also, I want to point out, as a result of this, that I started chasing down the history of AI in architecture some 12 years ago when I was reading this book and reading through the footnotes and realizing that here he is referring to people like Claude Shannon and John McCarthy and Ross Ashby, who are all key figures in cybernetics and in artificial intelligence. But jumping ahead to A Pattern Language, and then his, which he wrote with his colleagues at Berkeley, and The Timeless Way of Building, which was a philosophy, kind of a philosophy and theory of using patterns. And what he saw patterns as were 253 different kind of ways of doing things, from large scale to small scale in a philosophy, so they network together. And he wrote that each pattern describes a problem which occurs over and over again in our environment, and then describes the core of the solution to that problem in such a way that you can use this solution 1,000,000 times over without ever doing it the same way twice. So patterns look kind of like this in the book. There's a title, there's an image, some kind of photograph, there's a description of what the problem was, and different sketches going through. It shows how it relates to other patterns in a hierarchy. That star at the top by row houses means that they felt very sure about this pattern. But if they had 2 stars, it meant they wanted to include it anyway. They weren't so sure. Maybe someone was going to come up with something better in time. In the 1970s, late 60s, early 70s, they even had an idea that there might be a database of patterns that people could exchange and trade. So here's, for instance, how some of the patterns fit together, right, in the hierarchy. So if you look down on the lower right, you can see where we're a part of today, or where the row house pattern was a part of. So you see things like household mix, house cluster, housing hill. So these are describing patterns about houses. And then again, all of the patterns fit together in a network. It's not in a strict line, but there is a hierarchy. It's like running code. A program needs to run in a certain order in order to make sense. Well, Christopher Alexander is the only architect that many tech people know. And the funny thing is he's not well liked by architectural architects. They find his approach too reductionist. But 2 people who picked up on his work when they were in college were Ward Cunningham and Kent Beck. And I'll tell you a little bit more about them in just a minute. But they both would read Christopher Alexander's books in the University of Oregon bookstore or in the library and then put them back. They're all very expensive, so they couldn't afford them. And bit by bit worked their way through Timeless Way of Building and Pattern Language and Notes on the Synthesis of Form. In the late 1980s, in 1987, they were working on interfaces for Smalltalk, which was an object-oriented programming language, and they thought that using patterns would be a good way to try and capture their knowledge and what they knew about these different kinds of interfaces that they were trying to create. This idea took off. A group of 4 programmers started working together. They're referred to as the Gang of 4, and in 1994, they published a book called Design Patterns, Elements of Reusable Object-Oriented Software. And this book describes a design pattern as something that systematically names, motivates, and explains a general design that addresses a recurring design problem in object-oriented systems. And I think that by last count, when I plugged it into Google, I got something like 1,300 results. There are web patterns, game patterns, UX patterns, UI patterns, you name it. Does this begin to ring a bell? Is this something that, who here is actually using patterns in some way in your work? This is where it comes from. Kent Beck was really turned on by the ideas and the philosophies here from Christopher Alexander. And when he looked at the ideas in a pattern language, he described it, he was interested in the politics of it, that it changed up the power in the design process, and in fact said that it's a rearrangement of the political power in the design and building process. And he and Ward Cunningham applied these ideas, along with a number of other people who signed it here, to the Agile Software Manifesto. So if you participate in Agile, Scrums, if you ever did extreme programming in whatever format that it was, this is again motivated by Christopher Alexander's ideas about design. Ward Cunningham applied it to his invention of the wiki. He invented the wiki format. He wanted a way for a conversation to keep growing and not have any edge. He didn't want to put the edge in sight. And so he created the wiki format as a way of doing that. That's, of course, what Wikipedia uses and what we all use some way or another every day. This idea was also really attractive to people like Terry Winograd. He's an emeritus professor now at Stanford University. And he wrote a book in 1996 called Bringing Design to Software. A lot of this book is available online, and it's really still thoughtful, good work on what it is to do the design and the structuring of software in a human-centered way. I recommend taking a look for it. And he picks up ideas of Christopher Alexander in this book, which are really important for human-centered design or user-centered design. Talking about software is not just a device with which the user interacts, it's also the generator of a space in which the user lives. Software design is like architecture. When an architect designs a home or an office building, a structure is being specified. The patterns of life, again, there's that Alexander term, for its inhabitants are being shaped. People are thought of as inhabitants rather than the users of a building. This was radical. This was a big shift in how people thought about how to design software in the early to mid-1990s. And this coincides with the birth of the web and also the birth of UX design. So inhabiting the space of software, also influencing things like information architecture. In their first book on information, the first edition of their book on information architecture, Lou Rosenfeld and Peter Morville wrote about architecture as being a way to guide how we think about designing something unfamiliar. Why so much talk about the impressions that physical structures make on us? Because they're familiar to us in ways that their websites are not. Like websites, buildings have architectures that cause us to react. Buildings and their architectures therefore provide us with great opportunities to make analogies about websites and their architectures. And I will point out that no architect who designs a building refers to what they do as designing architectures. They also don't use architect as a verb. They design. That's what they do. But the idea of building and the idea of architecture is, again, vital in the early days of the World Wide Web to provide structure for what it is that we do. And it's probably something of interest still for people here today. It's also really influential to people like Christina Woodkey or Jesse James Garrett. Christina, I'll talk about in just a second. Jesse's one of the co-founders of Adaptive Path, now owned by Capital One, and he wrote the book, The Elements of User Experience, in 2002. I should admit I was its editor, but back in the early 2000s, they created a really important community called Boxes and Arrows, and it was a journal, website, resource about design and about information architecture that, again, picks up a lot of these ideas and are very important for where we get to today as people in UX. Different architect. This is Nicholas Negroponte. And Nicholas Negroponte is best known for being the founder of the Media Lab, the MIT Media Lab. In fact, if anyone was watching 60 Minutes, I hear that there was something about the Media Lab on last night. And one laptop per child, which was a move to put a laptop in the hands of children in the developing world in the 2000s. But before the MIT Media Lab, he started something called the MIT Architecture Machine Group with his colleague Leon Greusser. Nicholas Negroponte is an architect. He has a Bachelor's of Architecture and a Master's of Architecture from MIT. He's written a number of books. He's probably best known for writing a book called Being Digital in 1995. But I'm interested in these books he wrote in the 1970s. He wrote a book called The Architecture Machine, which is a theory about artificial intelligence and interfaces that he dedicated to the first machine that can appreciate the gesture. He's always got gestures in his photographs. Sneaks in. And Negroponte and the Architecture Machine Group were designing interfaces for AI, and they were also funded largely by the Department of Defense. Now, I should point out that all funding for artificial intelligence, almost all funding for artificial intelligence came through DARPA's Information Processing Technology Office, and particularly through the Office of Naval Research, which meant that military imperatives and military paradigms shaped artificial intelligence research. And the reason for this kind of paradigm I just want to point out is that this group of people really liked working with each other after the Cold War. It was a way to keep working in a closed way. It's what a historian named Paul Edwards calls the closed world. And they preferred to send money between each other and work with each other. So until about 1974, there's a paradigm in place called a microworld, where you work on these little worlds and often on blocks, as we'll see. And then we get into command and control interfaces that have to be tactical and have to have actual military purposes. You're going to see this in the projects that follow. J.C.R. Licklider, the man who came up with the notion of human-computer symbiosis, was a major funder. He worked at both MIT and DARPA. And Marvin Minsky was one of the people who also, I want to point out that both of these people were very close mentors of Nicholas Negroponte. So in 1967, Negroponte created something called the Urban 5 system. The Urban 5 system was a computer-aided design system that had a conversational user interface that engaged its users in a question and answer dialogue about design decisions that they wanted to make. So you see a light pen here, a set of buttons on the side that were attributes that you could apply to the different blocks that you were choosing on the screen. Like you could say, this should have light, this should have shadow, this is for inside, this is for outside. And here you see some of the ways, some shots of that screen working. And if you look in the lower right-hand corner, you'll see one that says, Ted, many conflicts are occurring. And Negroponte wrote that this blocks world of his, this conversational user interface, was a failure. It was difficult to get the system to respond in the way that it was meant to. And ultimately, he said it printed garbage, but at least it was friendly garbage. And the fact is, we know that doing conversational user interfaces is difficult. There are going to be sessions here today on voice user interface and conversational interface and chatbots. Who here has tried to do a chatbot or something in this realm? Is it easy? No, it's not easy, because you set off down the path and you realize that already you've left too much open, and you need to really kind of close things in. It was really, really hard in 1967, and he knew that too, but still talked about the possibilities of it. This is the software show, and this is from 1970. It's a project called Seek, I'm sorry. Project called Seek. And if you look closely, you'll see a lot of mirrored blocks and some kind of robotic arm that stacks the blocks. That's what Seek's job was, to stack the blocks. And there are a lot of gerbils living in there. I don't know if you can see them, but they're hiding inside, and it says, gerbils match wits with computer-built environment. So gerbils did what gerbils did, which is to move around the blocks and make them at home, and Seek did what Seek did, which was to stack them. And I should point out, this is a part of a bigger show. The software show was held at the Jewish Museum. It almost bankrupted the Jewish Museum. It was a disaster. The projects didn't work. And this is one of the gatefolds of the exhibition catalog that featured Seek, Life in a Computerized Environment. There's a quote from Ted Nelson in the article that accompanies the catalog that says, our bodies are hardware, our behavior software. And I think this is one of the problems with artificial intelligence scaling up to the level of living beings, because it didn't go so well, and Seek tended to kill the gerbils. So we then move ahead to the command and control age of the architecture machine group and of artificial intelligence funding in general. And in 1976, they started working on projects in what they called the media room. So you see here this big, this sort of dark orange carpeted room. This is an Eames lounge chair that has joysticks in it. And on the left, what you see is a project called the Aspen Movie Map. And you would sit in this lounge chair and zoom down the streets of Aspen, Colorado. The images would be delivered from a video disc. If you remember what those were, sort of big LP record-like discs that preceded the compact disc. They could hold 50,000 images. And then on the left and right, you see two touch screens that have maps, and you could steer yourself there. And this was funded in the wake of interest in possibilities in military simulation and in remote sensing and viewing. On the right, you see a project called Put That There, and there's video on the internet that I'm not including today, but it had some manner of abstraction. So you could say, put a red trawler, or put a red boat, and the system would say, where, in its computer voice, and you'd say, there. Put that there. Move that there. So it could figure out what was meant by that, by there, by that, by these different kinds of abstractions. That was used for ship fleet management. In 1977, they started working on the first digital layered maps. And this was a mapping window that had been provided to them by Westinghouse. It looks rather like a mapping window that I'm carrying in my bag right now. And I like the fact that you can also see an IBM Selectric typewriter in the background, so we know that we're in the 1970s. But these maps were intended to, as their proposal said, stand for all of the maps that one might have in the battlefield and be about the size of a pack of cigarettes eventually. There would be force feedback. There'd be 2.5D to 3D maps as one has today. And then there's also audio and tactile feedback in these maps proposed. These were largely designed by an architect named Guy Weinsapfel, a member of the lab. And I'm struck by something that Negroponte and his colleague Richard Bolt wrote in 1978. We're proposing to develop human-computer interfaces, on the one hand as sophisticated in conception as a cockpit, on the other hand as operationally simple as a TV. From either perspective, the object is the same, supreme usability. I don't know the genesis of that term before this particular report, but supreme usability definitely catches my eye. The Media Lab was founded in 1984, And the architecture machine group folded into it and became 4 of the first 11 labs at the Media Lab. The Media Lab had private funding from corporations, and as a result of that, was able to grow much bigger, is still in operation today at MIT. I'm going to introduce you to another architect. I'd like you to meet Cedric Price. And I'd be curious, has anyone here heard of him? Okay. He's my favorite. I think he's our secret patron saint. But I'll introduce you to him a little bit and see what you think. Cedric Price was famous for not building things. Most of what I'll talk about he didn't build. He asked things like this: technology is the answer, but what was the question? He once told some clients, maybe you don't need a new house, maybe you need a new wife, maybe you need a walk in the park, maybe you need a divorce, I don't know. But building a house or building a building was not his first go-to idea about architecture. He did build the Snowdon Aviary at the London Zoo, and then he also said that maybe you could take the mesh off after a while, and maybe the birds stay, and maybe they don't. So it goes. He had an idea about openness in architecture, that architecture wasn't something to lock down, that maybe architecture was something to challenge a user. I've spent many years working and doing research in the Cedric Price archive in Montreal, so a lot of my images are going to look like this. They're going to be photographs of things in the archive. But I'll point out that he's laugh out loud funny once a day, like when you find the Jungle Book characters living on the buildings that he's designed. He's probably best known for this unbuilt building called the Funbehalis, which was a large cybernetic theater that he worked on with Joan Littlewood, who was a radical theater designer and director. And this was supposed to be kind of a big open structure that you could plug things into. Over time, the idea was that it would come to know its inhabitants and users and shift to their needs, and the users would shift it to their interests. He even worked with a 27-member cybernetic community to sort out how all of this, how this should all work. So if you look closely at this in the middle, you'll see input of unmodified people and then output of modified people. So they had a cybernetic diagram for what this building would do to you. He worked really closely with a cyberneticist named Gordon Pask, and Gordon Pask was really important for architects and designers. He's also really important for ideas about conversation because he's the person behind conversation theory. So if you've had a chance to attend the IXDA conference, for instance, in New York, if you were at Interaction 17, you might have heard Paul Pangaro speak, and Paul Pangaro carries on a lot of Gordon Pask's work today. This is his Musicolor machine. It was a machine that you'd play music with and the lights would spin until it got bored with you. And then you'd need to figure out how to excite it again once it was bored with you. I like what he has to say about design because it's challenging. He wrote an article in 1969 that said, "Let us turn the design paradigm in upon itself. Let us apply it to the interaction between the designer and the system she designs, rather than the interaction between the system and the people who inhabit it. We tend to think that we want machines to do our bidding. I like the idea that maybe sometimes they might not." Inspired by some of these ideas, Cedric Price designed a project also unbuilt called Generator in 1976. It was supposed to be an arts retreat site in northern Florida, and you could move around these 12-foot cubes, walkways, barriers, and just kind of use them for whatever purposes you might have in mind. A very famous patron of the arts was paying for this idea. And he came up with a number of different kind of plans for it. So this one, there's a VG, very good, walk around to all the angles. And then this one with the orange check mark shows an intersection of paths and Generator. And it says, "Excellent, full of event and taught action." Just kind of imagining all the things that might happen with creativity and human behavior if they were going to be experienced at Generator. And the cubes of Generator would be moved around by a mobile crane. Cedric Price really liked things like hovercrafts and mobile cranes. And the construction of it would work something like this. There's a grid, The cubes go down, they're attached. You put on the roof and the sides, you connect the open areas, and then finally, you can put on some side baffling and open up the front and the stairs. It's also these little cubits that could be used to lay out generator and see what was going to work for you, for your own interests. And maybe you might even do something like this. They suggested what they called the bleeper walk in 1977. And then this is just a strange thing about a bunny rabbit or a mouse pushing a generator cube. But he realized that it was unlikely people were going to make the demands of the architecture that he'd hoped that they would not want to move around generator after all. So he worked with John and Julia Fraser, who were an architect, computer-aided design programmer couple. And they came up with a system for generator. And that system had 4 very powerful programs. One was an inventory program. So John Fraser suggested putting microcontrollers on all of the parts of generator, effectively sensors, right? And then the inventory program would keep track of what generator was doing. The architect program would have the rules of generator. This red thing you see here was a design system, so you could move these around, and then it would plot out on the monitor and on the printer where you had moved things. The 4th program was the most important, and it was called the boredom program. And the boredom program said, in the event of the site not being reorganized or changed for some time, the computer starts generating unsolicited plans and improvements. And they wrote to Cedric Price, if you kick a system, the very least you would expect it to do is kick you back. You seem to imply that we were only useful if we produced results that you did not expect. I think this leads to some definition of computer aids in general. At least one thing you would expect from any half-decent program is that it should produce at least one plan, which you did not expect. And my friend and colleague Madeline Gannon, who just received her PhD from Carnegie Mellon, did not know about Gordon Pask or about Cedric Price's generator when she did the project I'm going to show you right now, which she's basically a robot whisperer. And she put a large industrial scale robot in the Design Museum in London for 6 months and let people interact with it.
When everything comes together and you're in the space with the robot and you just have a very raw experience with this animal-like machine responding to your every move, all the technical aspects sort of melt away into the background. It's incredibly important to have opportunities and spaces to come in and experiment and misuse these existing technologies.
So this idea that you can misuse, that it's a good idea to misuse existing technologies to better understand how we interact with them and how they interact with us and what those boundaries and possibilities might be. So I think that a lot of this has to do with understanding what intelligence is and what it means for designers and what makes us human. And you might be familiar with the idea of the uncanny valley. This is the idea that if robots are too similar to us, it freaks us out. We find it a kind of eeriness. And this term was coined in 1970 by Masahiro Mori, who wrote in a Japanese article in a publication called Energy about this idea. But what he said about it is not that we should try and make our robots less human, but rather that we should use the robots to understand what makes us human. That we should build an accurate map of the uncanny valley so that through robotics research we can come to understand what makes us human. And you might be familiar with the blog AI Weirdness, which is by Janelle Shane. I highly recommend it. I cannot read it without getting tears in my eyes from laughing so hard. This is, she fed a neural network. She does neural networks that do strange things. So she fed it 7,000 paint colors and paint formulas. And it came up with a whole bunch of names for them, and all of the colors are awful. But you see things here like Turdley, Stanky Bean, Gasty Pink, Burble Simp. She's also done things like named guinea pigs. So this is from a set of data. Also it includes some Pokemon characters as well, but a set of data from the Portland Guinea Pig Rescue. So there's Princess Pow, but there's also Hanger Dan. Very nice name for a guinea pig. But she has an understanding of what she's doing by training these neural nets, right? And she says, she wrote something at the end of February that says, if life plays by the rules, image recognition works well. But as soon as people or sheep do something unexpected, the algorithms show their weaknesses. So here she's showing what happens if you color sheep orange, and then the Microsoft image recognition algorithm sees them as flowers in the field. Or if goats are in a tree, they become birds, right? You start seeing what the edges are of what trained that algorithm. You could also look back at what someone like Nicholas Negroponte wrote in 1975. I strongly believe that it is very important to play with these ideas scientifically and explore applications of machine intelligence that totter between being unimaginably oppressive and unbelievably exciting. And there are lots of examples of this. You might be familiar with Palantir, which was secretly testing a predictive policing algorithm in the city of New Orleans. The city just cut its relationship, but they did this for 6 years. You can consider something like deepfakes, where with enough image data, you can produce video that has never existed. This happens a lot with female actresses who get turned into porn stars. It has also happened with President Obama. I am also apparently an AI. I will just point this out, and I'll spare you the sexist drivel that's here. But a lot of times we tend to gender AI in certain ways and talk about artificial intelligence and assistance in certain ways. And it tends to be feminized and often problematic. I think all too frequently we say that that problem's been solved. And often in the past when I've given talks, I point out that I live in the city of the future because I live in Pittsburgh. And Pittsburgh is one of the places where we have self-driving cars, where Uber ATG is a mile from my house and I see multiple self-driving cars a day. But as we know, it was bound to happen, and finally we did end up an Uber car did end up hitting a pedestrian last month. But we can't automate everything. We know that, for instance, it's very, very difficult to pick raspberries. And it requires a human touch. You can think of how hard it is to determine when they're perfectly ripe and how not to crush them. And when you have artificial intelligence or machine learning algorithms that are so perfect for things like mining equipment, they'll be so good that it makes the vehicle fall into a rut. Okay, this is not the vehicle. This is obviously pre-machine learning. But if it's too perfect, if there's not enough noise, you end up with ruts. There are people like Mimi Onuaha, who is one of my favorite people I've met over the last year. She spoke last year at the I/O Festival, and I think she may be speaking again this year. Mimi collects uncollected data sets. And you might ask what an uncollected data set is. Could be things like the shootings of unarmed African American men. And if you are not collecting that data, then you can't parse that data. She's partly an artist and partly a designer and critic, so the right-hand side is her art piece, uncollected data set. Of course, if you open up the drawer, all of the folders are empty. She worked with a group of Asian actors on Broadway because the roles for Asian actors basically only exist in the play The King and I, and there's almost nothing else. So she worked with them to gather this data, and with this data, changes began to be made, and more roles were created thanks to the data having been collected. Here are some of the uncollected data sets that Mimi has on her GitHub. The missing data sets. So I guess a lot of the time in design, we talk about the how might we question. You know, we just sometimes even shorten it to HMW as a way of opening things up a little bit. And I find myself thinking, how might we about a number of things about what I'm talking about today. One thing is, how might we use AI as material for design? This is something that my colleagues John Zimmerman, Jody Forlisi, and Chan Yang at Carnegie Mellon are interested in, right? Where do we find the material of design in artificial intelligence? How do we get beyond the chatbot? We start with chatbots because they seem easy, and because there seem to be tools that allow designers and UX people to approach them, but it's not quite that easy. How might we better understand what makes us human as we engage with artificial intelligence, as we design with it? Where do we end? Where does it begin? What does it make us? I'm very interested in questions of ethics. So how can what we design and make be used as an ethical lever? How do we have an impact on AI when we're not the ones making the algorithms? And how might we be able to explore dynamics of intelligent systems, ideas about learning, expectations, boundaries, failures and successes, pasts and futures? I have to thank Tianyang for this, because really it is kind of a thing where anybody could potentially get a machine learning, and where we tend to talk about AI and machine learning as though it is magic fairy dust. I find myself thinking again about patron saint Cedric Price. If technology is the answer, what was the question? And I'll say thank you. I don't know if there's time for questions. I show that it's 9:18. Or there's time for coffee. Great, we'll call it coffee. Thank you very much.
Yeah, it's true there is, oh, sorry about that. It's true there's still lots of